The Sun is a star, a massive sphere of hot plasma in the solar system. Hydrogen and helium are the primary components of the Sun's plasma. Nuclear fusion occurs in the Sun's core, generating immense energy. The energy produced by nuclear fusion radiates outward as light. The Sun's energy also radiates outward as heat. The Sun's light and heat are essential for life on Earth. The Sun consists of several layers: the core, radiative zone, convective zone, photosphere, chromosphere, and corona. The core is where nuclear fusion generates the Sun's immense energy. The radiative zone transfers energy from the core via photons. The convective zone transports energy through the movement of hot plasma. The photosphere is the visible surface of the Sun. The chromosphere and corona are the Sun's outer atmosphere, extending far into space. Solar flares are sudden releases of energy from the Sun's surface. Coronal mass ejections, CMEs, are also sudden releases of energy from the Sun. These solar events can impact Earth's magnetic field. The impact of solar flares and CMEs on Earth's magnetic field can cause auroras. Solar flares and CMEs represent significant energy release events from the Sun. The Moon is Earth's only natural satellite. The Moon is a rocky body with no atmosphere. The lunar surface is characterized by craters, mountains, and maria. Maria are dark, basaltic plains on the Moon's surface. Craters on the Moon are formed by impacts from space debris. Lunar mountains contribute to the Moon's varied topography. The prevailing theory suggests the Moon formed from debris, following a collision between early Earth and a Mars-sized object. The impact ejected vast amounts of material from both Earth and the colliding object into space. Over time, gravitational forces caused this ejected debris to coalesce, eventually forming the Moon. This theory explains the Moon's composition and orbital characteristics. The Moon orbits the Earth in an elliptical path. Synchronous rotation means the same side of the Moon always faces Earth. Perigee is the point in the Moon's orbit when it is closest to Earth. Apogee is the point in the Moon's orbit when it is farthest from Earth. The Moon's distance from Earth varies significantly between perigee and apogee. Lunar phases result from changing angles at which we view the Moon's illuminated surface. The new moon occurs when the Moon is between the Earth and the Sun, making it appear dark. The crescent phase appears when a small sliver of the Moon is illuminated. The quarter moon is visible when half of the Moon's face is illuminated. The gibbous phase occurs when more than half of the Moon is illuminated, but it is not yet a full moon. The full moon occurs when the Earth is between the Sun and the Moon, fully illuminating the Moon's surface. A solar eclipse occurs when the Moon passes between the Sun and Earth, blocking the Sun's light. A total solar eclipse completely obscures the Sun, revealing the solar corona. A partial solar eclipse occurs when only part of the Sun is blocked by the Moon. An annular solar eclipse happens when the Moon is farther from Earth, leaving a bright ring of sunlight visible. The type of solar eclipse depends on the alignment and relative distances of the Sun, Moon, and Earth. Solar eclipses provide opportunities to study the Sun's corona and test astronomical theories. A lunar eclipse occurs when Earth passes between the Sun and Moon, casting a shadow on the Moon. During a total lunar eclipse, the Moon passes entirely through Earth's umbra, appearing reddish. A partial lunar eclipse occurs when only a portion of the Moon passes through Earth's umbra. In a penumbral lunar eclipse, the Moon passes through Earth's penumbra, resulting in a subtle dimming. The alignment of the Sun, Earth, and Moon is crucial for a lunar eclipse to occur. Lunar eclipses are observable from anywhere on Earth where the Moon is above the horizon. The Moon's gravitational pull generates tidal bulges on opposing sides of Earth. These tidal bulges are the primary cause of high tides. As Earth rotates, different locations experience alternating high and low tides. The side of Earth facing the Moon experiences a direct tidal bulge. A secondary tidal bulge occurs on the opposite side of Earth due to inertia. Spring tides occur when the Sun, Earth, and Moon are aligned. This alignment during spring tides results in higher high tides and lower low tides. Neap tides occur when the Sun, Earth, and Moon form a right angle. The right angle alignment during neap tides results in less extreme tides. Historically, the Sun's apparent motion across the sky defined days and years. Early timekeeping devices, like sundials, track the Sun's movement to measure time. Sundials use the position of the Sun to cast a shadow on a marked surface, indicating the time of day. The apparent motion of the Sun provided a fundamental basis for early calendars and time measurement. The consistent and predictable movement of the Sun enabled the creation of standardized time units. Many cultures have historically used the Moon's phases to create lunar calendars. Lunar calendars track time based on the cyclical phases of the Moon. The Moon's phases provide a natural and observable way to delineate months. Lunar cycles offer a consistent and predictable method for timekeeping. Tracking lunar phases allows for a natural rhythm in calendar systems. The Sun's energy is the primary driver of Earth's climate system. Solar energy influences Earth's temperature and atmospheric conditions. Changes in solar activity can affect Earth's climate and weather patterns. Variations in solar irradiance directly impact global temperature. Solar activity influences atmospheric circulation and precipitation patterns. The sun will eventually exhaust its nuclear fuel. As the sun exhausts its fuel, it will evolve into a red giant. After the red giant phase, the sun will collapse into a white dwarf. The sun's evolution will significantly impact the solar system. The transformation of the sun will alter the conditions for life in the solar system. The moon is gradually moving away from Earth over vast stretches of time. In the distant future, lunar eclipses will no longer occur due to the moon's increased distance. The Earth's rotation is slowing down, leading to an increase in the length of Earth's day. Gravitational interactions between Earth and Moon influence both orbital distance and rotational speed. These changes are gradual, unfolding over millions or billions of years.